Okay, this is an example of an applied force on a block on a horizontal surface. As in the earlier derivation, this is a block resting on a surface. Mass times gravity is acting down, so the force due to gravity is acting down. The normal force is in the upward direction. And we're going to have an applied force. We'll just say that the applied force is in this direction. The applied force would be like someone is pushing on it from behind and they're pushing this way, or maybe there's something attached to it and you're pulling on it like this. Well, the force between the surfaces, the bottom of the block and the top of the table, is called the force of friction. It's a contact force, and the force of friction we'll describe in a couple of minutes, a little later. It's dependent upon how much gravity is acting downward. Now, first of all, let's sum the forces. The sum of all forces are equal to mass times acceleration. And we'll first look at the sum of the forces in the x direction. We have the force applied going this way and the force of friction opposing it. So force applied minus force of friction equals mass times acceleration. These are the only forces in the x direction. There are only two. Now, the force of friction. By experiment, the force of friction is equal to mu Fn. But let's try to understand this conceptually. The force of friction is a frictional force between these two surfaces. Gravity is acting down on the block. The harder gravity acts down on the block, the harder it's going to push down on the surface. So the harder the value, the greater the value of gravity, the greater the frictional force. So the frictional force must have something to do with gravitational force. Well, when we go back and look at summing the forces in the y direction, the normal force minus the force due to gravity equals mass times acceleration. If it's not moving in the up or down direction, it's not moving in the y direction at all, it's only moving in the x direction, then it's not accelerating in the y direction. That just means that Fn equals Fg, which equals mass times gravity. This means that the normal force is equal to mass times gravity. So the normal force in relation to the force of friction is equal to mu mg. And here you can see that the force of friction is dependent upon the gravitational force. So the stronger gravity is, the more contact you have between the surface of these two objects. The less the value of gravity, the less contact you're going to have between the surfaces of the two objects. All right, and the coefficient, it's just a number, it's just a multiplier, a scalar multiplier, in order to get the value of the coefficient of friction. Okay, so we plug that into here. So force applied minus mu mg equals ma. If we're solving for the applied force, we add this to the other side. Force applied is equal to ma plus mu mg. And if you're solving for acceleration, then you take this, skip that step, take this, go from here, solve for acceleration, divide everything through by mass, and the acceleration is going to be equal to force applied minus mu mg divided by mass. Now, some people, they want to just cancel that mass with that mass, and you can't do that because a negative sign is separating these two terms, and there's not a mass in that term. So you can't just cancel out the masses. It is just as it is. It has to stay that way. Let's just look and see if we have any other situations. We've summed the forces in the x direction, so force applied minus force of friction. And we've gotten two different things that we can solve for, force applied and acceleration. And we sum the forces in the y direction. This is what we got earlier, that's just equal to mass times gravity. Now, this assumes that the object has an acceleration. There's one other case that we can look at right now. We can assume that the object is traveling with a constant speed. If it's traveling at a constant velocity, the acceleration will be equal to 0. And if we took that, rewrote it down here, let me draw a line. The sum of the forces in the x direction are equal to force applied minus force of friction, which equals ma. If acceleration were equal to 0, then the force applied minus force of friction will be equal to 0. add force of friction to the other side. Force applied equals force of friction. So the force applied would be equal to mu mg. Right? This is the case for there being a constant velocity.